What is math? I think most people can't answer that. Most schools don't teach that, which is why most people don't like math. The field is presented as this barrage of random rules and senseless constructions that would drive even the most intrepid mind to turn off and withdraw inward. Mathematics is not some castle in the sky tautological study for academics in their ivory towers. It's a very real thing with real applications in your life. I'll give you an example. How many marbles can you see? Okay, 3. Now 5. How about now? Some of you can probably look at this and immediately know 7. How about now? Yeah, no one can make sense of that. Not right off the bat. But if you take this mess and organize everything into groups, say of 5, now it's very easy to tell how many there are, right? That. You did math. It might have been automatic, you might not have even noticed, but you multiplied 5 and 3. I told you there were 5 marbles per pile, and you can perceptually identify that there are 3 piles. So 15. That is math. That is a very real, very tangible thing that is directly applicable to your world, to your life. Mathematics is the science of indirect measurement. The human perceptual faculty is extremely powerful. You know that. You experience it directly. You can look at something and identify that's a tree, that's a car, this is a desk. We immediately know this. Our conscious minds are instantaneously informed of these perceptual entities. And as we just established, that includes a limited understanding of the number of those entities. And there are a lot of limitations, especially in terms of measurement, of precision and accuracy. How tall is the tree? How far away is the grocer's? These are things that are impossible to grasp perceptually. A mile or longer, that's an impossible distance to really hold in your mind. Try. Smaller than a millimeter? Also impossible. We need a means of indirectly understanding these magnitudes, of indirectly operating at and manipulating devices at those scales. That tool, that science, which provides us those means, is mathematics. Geometry allows us to rise from the perceptual realm, isolating shapes and lines and allowing us to understand the relationships between them. Algebra further isolates the magnitudes themselves to study their relations. Calculus is the study of how changes in those magnitudes relate. Our conceptual lever into reality grows as each field builds upon the previous ones. Using math, we were able to build out the other branches of science, of physics, of engineering, of biology, and chemistry. How else could we build massive machines that fly to the moon, that can harness the power of the atom, of the sun, of nature? How else could we even understand the mechanisms at play? You can't see a molecule, yet we rip them apart, harnessing that power into a controlled explosion that propels us far faster than our natural abilities, than evolution could possibly have enabled us to. We can manipulate things far smaller than the naked senses could ever comprehend on their own. We have peered into the universe far more deeply than our eyes and ears could ever hope to perceive. Mathematics is what enables all of it. It is not some arbitrary set of self-consistent rules. It is a conceptual framework, induced from the nature of reality and the relationships we identify in the world. These relationships build upon one another. The result is an integrated structure that is not meant to isolate one's mind from the rest of existence, but to illuminate the deepest truths of our universe.